Everyone. Hello everyone. So in continuation with what we were discussing in the previous video, this is the video in which we'll be discussing a few more dimensional formulas, out of which the first one is energy. So whatever type of energy we have, we'll have the same dimensional formula for this. In this case, it has already been proved for kinetic energy and potential energy. So formula for kinetic energy is half mv square. Since half is a constant, so it will not be having any dimensions. Mass will be having the dimension for m, and v is the velocity. Go through the previous video. The dimension and formula for velocity was lt minus 1, so it would be lt minus 1 square, which will lead to this dimension formula, that is ml square t minus 2. So this is the dimension formula for energy. Similarly, potential energy, we can say this is mgh. M is mass, g is acceleration due to gravity, and h is height. Again, m is for mass and acceleration due to gravity. Acceleration is having the dimensional formula for lt minus 2. You can again check this from the previous video. And lt minus 2 into h, this would be length, that is L. So again it will lead us to this formula, that is ml2 t minus 2. Next is power. Power is work done per unit time. Work done has the same dimension as that of energy, because work done is equal to change in kinetic energy or change in potential energy. So work will be having the same dimension for energy. So energy divided by time means ml2 t minus 2 divided by time. So we will reach this formula, ml square t minus 2. In the same way, you can calculate the formulas for density. Density is mass by volume. Mass and volume would be L cube. So it would be m L minus 3 T0. Time would not be having any power in this. So T would be 0. Pressure is equal to force acting per unit area. So force has the dimension for ml T minus 2 upon area would be L square. In this way, ml T minus 2 upon L square. So it will lead us to this formula, that is ml minus 1 t minus 2. So I'll tell you a few more. You can just try to remember as many as you can. Of course, you won't be able to remember all of these formulas, but try to remember the maximum of these. Next is torque. Torque is known as rotating effect of force. We'll learn in detail in chapter 5. So formula is force into distance. So force you already know, into distance it will be ml2 t minus 2. Angular displacement, this you must have learned in your mathematics class. Theta is equal to arc upon radius. So it is not having any dimension, it is a dimensionless constant, so it will be m0 l0 t0. Angular velocity would be angular displacement upon time, and angular displacement is represented by theta upon time. Theta has the dimension for m0 l0 t0 upon time, so it would be m0 l0 t minus 1. So if you have any reference book with you, any reference book, SL, Aroda, or whatever you have, the dimensional formulas would be given in the book as well. For you, I am just giving you these many. Angular acceleration is this one. You can note it down in your notebooks. Moment of inertia, it is the only tensor quantity that we have. The expression for moment of inertia is m into r square, where mass is m is the mass and r is the distance. So it would be kg meter square. तो dimensional formula उसका ये आ जाएगा, this one. Frequency is equal to 1 by time period. So 1 by time period would be m0 l0 t minus 1. I hope now you are getting to know these dimensional formulas, how they are being calculated. We'll discuss one more, and rest all you can write from your book or anywhere you want. You can write it from here as well. So these are the dimensional formulas that you need to write. I have to discuss the one dimensional formula, that is gravitational constant, which will be used. This is the formula, gravitational constant. We know that F is equal to g m1 m2 upon r square. This is law of gravitation that we have learned in class 9th. So F, the formula for g would be F into r square upon m1 m2. If I write the formula for g, it would be, of course, F into r square upon m1 into m2. Okay, so formula for F we already know, ml t minus 2 into r square would be length square. divided by mass square. If you try to calculate this formula, it would come out to be m minus 1 L3 T minus 2. So you can try this formula, you can try calculating this formula, you will easily get this result. Apart from that, we have this surface tension. Surface tension is force acting per unit length. We already know the formula for force and length, so it would be mLT minus 2 upon L. This would be mt minus 2. Okay, so force constant F is equal to kx. Force divided by length would be the value for k, means 4 divided by x would be the value for k. So this will be your formula. ठीक है, तो ये सब कुछ समझ आ रहा होगा तुम लोगों को. This is the expression for coefficient of viscosity. Coefficient of viscosity is the measure of the what you can say magnitude of force acting between the layers of fluid. For example, this is a surface of fluid which we can see from the side. We know that this upper layer is moving with the maximum velocity when the water is flowing in this direction. So velocity of upper layer is maximum. As we go downward, the velocity of lower layer is almost zero. It means the upper layer would be pulling this lower layer, this layer would be pulling this lower layer, and ultimately after time t, if the upper layer has reached somewhere here, the lower layer would be somewhere here, then it would be like this. Means as we are going downwards, the velocities of the lower layers would be decreasing in this way. So this results into the friction between these two layers, means these two layers will try to rub on each other. So this is the cause of this viscosity. This is the cause of this viscosity. So viscosity is defined as the frictional force acting between the layers of fluids. Okay, so I hope this is clear to you. You can as I've already told you, you can write as many formulas as you can, but don't try to jump over the conclusion of each and every formula. Try to get the gist of the formula, and from the formula try to get its dimensional formula. Means first of all we should know the formula for that particular expression, or that particular physical quantity rather, that we are trying to calculate. For example, in this case, let's take the example of coefficient of viscosity. The force of frictional force, that is the force of viscosity acting between any two layers of fluid, can be written as eta. This symbol is known as eta. This is the symbol and it is known as eta. Okay, so eta into dv by dx into a, and this dv by dx, any change with respect to distance is known as its gradient. Okay, so this is the change of velocity with respect to distance. It means as we are moving downwards, as I was telling you in this figure, as we are moving downwards, the velocity keeps on decreasing. It means as we are coming down, the velocity is changing. So whatever change in velocity is there with respect to the change in distance, this is known as gradient of velocity. So force of friction depends upon eta, that is coefficient of viscosity, gradient of velocity, and the cross-sectional area. When you will try to calculate the dimensional formula for eta, it will be F into dx upon dv into a. So when you will be putting the values for all these physical quantities in this case, you will easily get the expression for this. And try to remember one more thing. dv is change in velocity, so dv would be having the same dimension for velocity, and dx is change in length. Dx would be having the same dimension for length. Means the dimensional formula for velocity is Lt minus 1. So the dimensional formula for change in velocity would also be Lt minus 1 upon dx is the change in length. So the dimensional formula for change in length would be again L. This one. This is the dimensional formula for change in length, that is L. And if this get cancelled, dv by dx would be having the dimension for t minus 1. This. And area, as we already know, it is having the dimensional formula for L square. And force we already know, it is mLT minus 2. When you will rearrange all these things, you will get this formula ml minus 1 t minus 1. Okay, so you try to calculate these expressions for dimensional formula for different physical quantities, and in the next video we'll try to learn the applications of such formula, means where these formulas are applied. Whatsoever formula you have learned till date, all the formulas can be derived from this dimensional analysis. So try to remember as many as you can. अगर कोई याद नहीं भी होता है तो घबराना मत, as the time passes we'll be able to recognize such formulas. So go through these and go through the extra formulas that are there in your reference book as well. We'll continue it in the next video. Thank you.